Hello students, good morning. Today we will study about the interesting topics of mathematics, that is volume and surface areas of solids. In this topic we are going to study about the types of solids like a sphere, cube, cone, cylinder and rectangular prism. Actually, this topic is full of imagination and so-called 3D mensuration. One by one, we discuss them and learn formula and problems based on them. So let's start. Before starting any problems on solids, think real life examples of that solid. It will help, it will quite help us to solve it very easy. For example, real life example of keyword. I am asking to you students, what is the real life examples of the keyword? So room is the real life examples of keyword because its length and breadth. Room has length and breadth and height. So the real life examples of keyword is room. Real life examples of cone, birthday cake. Real life examples of cylinder, it is pipe. And the real life examples of a sphere is simply a cricket ball. Just imagine all the real life examples of cones. Now we will study about the different solids like this is a sphere, cube, cone, cylinder, rectangular prism. First of all, we start with keyword. Here it is keyword, just like the room. In this room, this is the width, also called breadth. This is length, and this is D, height. Here L is the length, W is the breadth, and D is the height. So surface area of keyword is equal to 2 into length into width plus 2 into length into D plus 2 into width into D. So after solving it, it is 2 into LB plus BH plus LH. That is 2 into length into breadth plus breadth into height plus height into length. And the volume of cuboid. What is volume of cuboid? It is length into breadth into height. So length into W into D. Now come on the cone. This is just like the birthday cap. This is cone in which what is R? R is the radius of the circular base and H is the height of the cone. So apply, this is the right angle triangle. In this right angle triangle, this is right angle triangle. This is S. What is S here? It is slant height, also called L, a small L. So by applying the Pythagoras theorem, we calculate S square equal to R square plus H square. Or what is S? Means what is slant height? It is under root R square plus H square. Now we are interested to calculate the surface area of cone. What is the surface area of cone? It is pi r l plus pi r square. We calculate the also base, that is pi r square plus pi r l. It is surface area of cone is total surface area of cone. That is the base, circular base plus curved surface area of cone, that is pi r l, also pi r s. Now volume of cone. What is volume of cone? It is 1 by 3 pi r square h. Next come to cylinder. Just imagine the pipe. That is cylinder. Cylinder is h. What is h here? In this figure, it is h. What is h? H is the height of the cylinder. What is r here? R is the radius of the circular base. Surface area of cylinder. What is surface area of cylinder? That is the curved surface area of cylinder plus area of the top base and the bottom base. That is top and bottom base is a circle. So pi r square. So pi r square plus pi r square. It is 2 pi r square plus curved surface area of cylinder. What is curved surface area of cylinder? 2 pi r h. Now, volume of cylinder. Volume of cylinder is pi r square h. Now come to the sphere. Just think about the cricket ball. It is the best examples of the 3D figure sphere. What is R here? R is the radius of the sphere. Its surface area is 4 pi r square. Its volume is 4 by 3 pi r cube. Now come to the example. My first example is question number 1. A vessel is in the form of a hemispherical ball mounted by a solid cylinder. The diameter is 14 centimeter and the height of the vessel is 13 centimeter. Find the capacity of the vessel. That is, let us draw a vessel. A vessel in the question it is given that hemispherical ball means it is hemispherical ball means it is that the hemispherical ball is on the top surface of the cylinder. That is its base of the hemispherical ball and base of the cylindrical that base is same. That is it is coinciding. So in the radius of the sphere, what is the radius of hemisphere? The radius of hemisphere is 7 centimeter because diameter is 14 centimeter and the base is same. So radius is 7 centimeter. Now total height of the vessel. Total height of the vessel means at this point to this point. So total height is 7 centimeter also because this radius, this is also the radius and radius is also the height of the hemisphere. So it is 7 centimeter and the height of the cylinder is and height of the vessel. Height of the vessel is means at this point to this point it is given that 13 centimeter. So 13 centimeter minus 7 centimeter equal to the height of the cylinder, that is 6 centimeter. So height of the cylinder is 6 centimeter. Radius of cylinder. What is the radius of cylinder? Radius of cylinder is simply the radius of the hemisphere is equal to 7 centimeter. Now, in the given question, it has to be calculated the capacity of the vessel. What do you understand by the capacity of the vessel? Capacity of the vessel is nothing but the volume of the vessel. Volume of the vessel. That is, in the vessel, what are the solids it is given? First of all, it is hemisphere and then it is cylinder. So, volume of hemisphere plus volume of cylinder. Now, we know that what is the volume of a sphere? 4 by 3 pi r cube. Here it is hemisphere. Then, what is the volume of hemisphere? Just half of it. That is 2 by 3 pi r cube. That is 2 by 3. Put pi equal to 22 by 7. What is r? It is r. 7 centimeter. That is radius of hemisphere is 7 centimeter. So 2 by 3 into 22 by 7 into 7 into 7 into 7 plus. What is volume of cylinder? Volume of cylinder is pi r square h. Pi 22 by 7 r square. R is 7 here. The radius of cylinder is 7. So 7 into 7, what is h? Height of the cylinder. We calculated earlier. Height of the cylinder is 6 centimeters. So put this value 6 centimeter here. After calculating all these the numerical value, we get the 2156 upon 3 plus 924 centimeter cube because the unit of the volume is or capacity is centimeter cube. So after calculating, we get 1642.67 centimeter cube. That is, my final answer is capacity of the vessel is 1642.67 centimeter cube. It is answer. Now the next question is, a toy is in the form of a cone mounted on a hemisphere of radius 3.5 centimeter. The total height of the toy is 15.5 centimeter. Find the total surface area and the volume of the toy. In the SID figure, this is the total toy. Think, just see carefully that it is toy. Toy is made of the two parts. The upper part is cone and the lower part is hemisphere. So one by one, in the given question, what is the given that radius of hemisphere? It is radius of hemisphere means from this to this length is 3.5 centimeter. Also, this to this length is 3.5 centimeter. What is base radius of the cone? It is also 3.5 centimeter because this base is also in the consideration of the circular base of cone. So it is also 3.5 centimeter. Height of the cone. What is height of the cone? Height of the only cone. Just see that the total height of the toy is, it is toy. The total height means total height of the toy means from this point to this point. It is 15.5 centimeter. And from this point to this point, the distance is 3.5 centimeter. Now we are interested to calculate the height of the only cone. It is here. What is the height of the cone? Just subtract 15.5 centimeter. Just subtract 3.5 centimeter from 15.5 centimeter. So 15.5 centimeter minus 3.5 centimeter is equal to 12 centimeter. So height of the cone is 12 centimeter. Height of the cone is 12 centimeter. Now, what is the slant height of the cone? Means this is called the slant height. What is slant height of the cone? Just apply the Pythagoras theorem. This side we know that 3.5. This height is we know that 12. So L is equal to under root r square plus h square. R is the radius, h is the height. So what is r? R is 3.5, that is 7 by 2 ka square plus 12 ka square whole power 1 by 2. So slant height is equal to, after calculating all these values, it is 25 by 2. So slant height of the cone is 25 by 2 centimeter. Now we have to calculate the total surface area. What is total surface area of the toy? Total surface area of the toy is curved surface area of hemisphere plus curved surface area of cone. Now curved surface area of hemisphere is, curved surface area of hemisphere is 2 pi r square plus pi r L. 2 pi r square plus pi r L means it is total surface area, means it is fully packed, so we cannot touch it. If we touch any side of it, then it is consideration in the total surface area because it is fully packed. So 2 pi r square plus pi r L. Curved surface area of cone pi r L. Curved surface area of hemisphere 2 pi r square. Just put the values of r and L. We have pi r into 2r into plus L. After putting the value of pi, it is 22 by 7 into 7 by 2 into 7 plus 25 by 2, that is 429 upon 2 centimeter. So total surface area of the toy is, it is 215.5 centimeter square. Now we are interested in the volume of the toy. What is volume of toy? Volume of hemisphere plus volume of cone. Volume of hemisphere 2 by 3 pi r cube, because volume of a sphere is 4 by 3 pi r cube. So 2 by 3 pi r cube plus volume of cone. What is volume of cone? 1 by 3 pi r square h. So put the value of r and h, we get the answer, that is 1463 upon 6 centimeter cube is equal to 243.83 centimeter cube. Hence the volume of the toy is 243.83 centimeter cube. So this is my final answer. Okay, thank you students.